안녕하세요. 나의 이름 요한입니다. And that's about it. 감사합니다. It's quite unusual for me. So usually I'm one of these guys. So I'm very, very happy to be moderating. Maybe can we close the door? There's some echo over there actually, or maybe I'll just ignore it. It's okay. I'll just hold my mic a bit lower, and then there's no echo. I'm a bit like a kid here. So some of you know me for trading as such. So I was more into trading from the age of 12, but actually from the age of 7, I was this kid at school who basically wanted to be an astrophysicist. Sadly discovered that I needed to go through a postdoc and got a bit discouraged of like working at NASA. And then, redirecting my efforts towards trading, and some would say gambling. It's not the case, but it's more structured, investing and so on. But kept a love for space. So I think, before that, it's just quite interesting to see that how we can, decomplexify a lot of the subtleties and the intricacies of space in general. So we'll cover quite a lot of subjects. So we've got a really, really, really decent panel here today. Quite difficult to get all these people in the room in one place. But a lot of fun, and about 5 hours of material to discuss in the green room, just over half an hour. So we'll try to condense a few things. We're trying to keep it really precise. Do we have any time for Q&A after? I don't necessarily think we do. Okay, so we'll try to be short and sweet, and we'll try to give some space for Q&A at the end. But we'll go through a few rounds. Can just go through a few rounds of intros. Maybe starting with you, General. Do you want to give a little intro on your past as such?
So background. So I went to West Point. I had a good engineering education. I went to Oxford to study humanities and economics and politics. I served 34 years on active duty as an officer in the Army. I fought in Vietnam. I came home on a stretcher. I taught at West Point. I ended up, my last couple of assignments, I was the commander of the U.S. Southern Command, so I had oversight of Latin America. And then I was the commander of U.S. European Command and Supreme Allied Commander Europe for NATO. So I had Africa in that responsibility, as well as the Balkans and the rest of the European countries. So I've been out of the military now for 24 years. I'm a licensed investment banker. I've been with more than 100 companies, and I love business development. I love the scientific side. I wanted to be a theoretical physicist before I went to West Point, but I realized that there are other people that could do that, but I was just thrilled to be able to keep my scientific interest up while I was in the military. I did a lot of science and technology development, and here I find myself with a fellow astronaut who I always loved the idea of space travel. And so you have this, we've got blockchain technology, which is the sort of ultimate in a trust-based economy. And we've got cube satellites, which until about 10 or 15 years ago, the US military said, we can't permit these in space because of the danger of nuclear proliferation. So we've got 3 great technologies we're talking about. And for me, what's in it is this is a way to bring the communications revolution to 2 or 3 billion people around the world who are just cut out from access. That's what this is about, integrating mankind and all the benefits that come with it.
Thank you, General. Maybe should we go to Sid? You want to introduce yourself in a few minutes?
I'll go next.
Thank you.
Sid Gutierrez. I went to the Air Force Academy, so a different academy than West Point, but along the same lines. I always wanted to be an astronaut, and when I graduated from the academy, I flew F-15s for a few years. I was a test pilot for a few years, and then I got selected by NASA, and I had the opportunity to be the pilot of the Columbia on a medical sciences mission, and the commander of the Endeavour on a mission to planet Earth. We used a synthetic aperture radar to image sites around the world. But perhaps more important, right after I wound up at NASA or was selected, about a year and a half later, we had the Challenger accident. And I had the opportunity to participate in the investigation of that accident and also the return to flight effort. So I spent a lot of time with a lot of great people around the country trying to improve the safety of the space shuttle. When I left NASA, they put me on the Aerospace Safety Advisory Panel, and we made a number of recommendations to NASA that they did not follow through on. And we warned them of a future accident, and they wound up with the Columbia accident, which was sad for me because I had flown that particular vehicle. But at that point, I came to the conclusion that the only way to increase the safety of access to space, by the way, when I was a kid, I was worried that by the time I became an astronaut, that everything would have been discovered and done by then. We would have stations on the moon and Mars, and you know, when I went in, they would say, "Okay, Sid, you've got the run to Mars today. You know, you're taking water out to Mars or something like that." And I'd basically be like a truck driver. Not that there's anything wrong with truck drivers, but that's not what I had in mind. And instead, we haven't even been back to the moon. And the reason is because getting from Earth to near Earth orbit has become very difficult, and we really haven't changed the technology since the 1950s. We've been using liquid bipropellant engines and solid rocket motors, and all the rockets you hear about out there are some version of that technology. And I was convinced, after having been associated and participated in the investigation of those two accidents, we needed to do something different. I was convinced the answer was a hybrid rocket motor, and I thought if we could make access to space safe, reliable, and affordable, then we could make the benefits of space, including small satellites, CubeSats, internet communications, regular communications, Earth observations, available for the underserved populations in the world. And in particular, I thought of countries in Asia, all the islands in Indonesia that would be hard to ever be connected with cell phone towers or anything like that. And at any rate, so I got involved. I found some folks who had a similar idea. We formed a company called VIA, and we've invented about three or about half a dozen technologies that have enabled us to make a hybrid rocket engine, which is an entirely different technology from what you see today. It's essentially, in a hybrid engine, the fuel is a cylinder of solid fuel with a hole in the middle of it, and you inject into that hole a liquid oxidizer, and then you ignite it. And the hole that runs through the fuel becomes the combustion chamber. So it's very simple, has about 1,000 fewer parts than a liquid bipropellant engine. And if you burn the fuel we have, it's a very green product. It doesn't give off toxic gases or anything like that. So we're very excited about it. We believe we can get performance similar to liquid bipropellant engines at a much lower cost, much improved safety, and much improved reliability, which we believe will enable us to put these small satellites, these CubeSats and things like that, into the orbits they need to go into. So if you have a very large satellite that does a lot of things and it's out at geosynchronous orbit or something like that, it's hard to communicate with, but it covers a large portion of the Earth when you're looking from 22,000 miles out. But if you're about 150, 200, 300 miles above the surface of the Earth, you see a lot less of the Earth. So you need a constellation of satellites in order to do your work then. So these small sats are nice in that they're less expensive, but they're a challenge in that you need to build a constellation of them, and you need them in different orbits. So what's offered to most satellite operators today is a large satellite where they can put up a large number, like maybe 60 satellites at a time, all in one orbit. And that doesn't work for companies that are trying to build internet coverage or communications or Earth observation. So we're building a right-sized rocket. We call it the Dauntless, and it'll take up a fewer number of satellites, but it'll be lower cost, more reliable, and we can put them in the orbits that a customer needs. So that's what we're excited about, and we found TE and GLUA and Space Telecommunications Incorporated, and they're interested in serving that population that amazingly, when I was thinking about what the clients for our rocket would be, I was imagining clients that would serve underpopulated or underserved populations in places like Indonesia, where it just doesn't make sense to build cell phone towers and fiber optics and all that sort of stuff. And that's part of their vision too. So we want to work together to expand the internet and make it available to these other populations in the world, as the general was talking about.
That's great. Let's maybe go to Tay then as a segue. If you wanna tell us a bit more.
Hopefully most of you already here knows me, but I'm Tay. I'm founder of Glua, and we invented CreditCoin. Our company's mission is about connecting people, and we found blockchain as a technology to enable it. So the first version of our product, CreditCoin, version 1, was about connecting the capital of the developed market to the underserved population in the emerging market, which might have a better yield, but has no access to capital. And the next version of CreditCoin we recently released is a EVM-compatible Layer 1 blockchain that allows not only to talk to people on the other side of the globe, but also talk to other blockchains. So currently, the blockchain ecosystem is siloed by blockchain. So there's no way for you to talk to for example, from Solana to Ethereum and so on and so forth. There are technologies like bridges and oracles that go around this problem, but they're not directly solving it. So we also invented this new technology called universal smart contracts that allow you to read information from other blockchain, but also enable you to call functions in another blockchain, basically writing on other blockchains. And also, while we were working on the capital market problem with first version of CreditCoin, we have realized that many portions of the underbanked are also unconnected, not allowed to get access to a financial service with the digital means. So we were investigating what's the viable options for these people. And luckily in our company, we had Scott on the left end of this panel, who had a background in aerospace, and he was educating me, inspiring me about this possibility of a new frontier in the aerospace. The space is getting commoditized, and now there's several concepts that we can utilize to build a decentralized version of a satellite constellation, which allows for us to provide connectivity to remote areas.
Yeah, so let's maybe move to Mike. If you want to tell us about more about what you do, who you are, and then and maybe just to segue into like how you interact with essentially decentralized technology in general.
Yeah, absolutely. Hi, everyone. Mikey Nyack. I started my career as a NASA space shuttle engineer, and after that, in no particular order, joined the Air Force. Got a PhD in astrophysics and planetary science. I did have the opportunity to think about space. I worked on some of the Air Force's first small cube satellites, been to test pilot school, did F-16 flight test, spent a season in Antarctica, and now I work at DARPA. And if you haven't heard of DARPA, the Defense Advanced Research Projects Agency, they're the folks that initially came up with things like the internet, GPS, lasers, microwaves. And part of the mission of DARPA, and this is kind of circling back to your question of how I intersect with these technologies, is the job of a DARPA program manager is really to envision a future. Look at the trend of technologies that we're seeing today, imagine a different future, and then try to build those technologies that can bridge the gap. So imagine a future, and then drag that future into the present. One of the big things, one of the themes of my career have really been space and space technology, next generation space technology. And I've been spending the last few years at DARPA thinking about a commercial lunar economy. And the only reason, it's a relatively new thing to be able to put those words in a sentence, because up until just 2 or 3 months ago, the only people who had been to the moon were large government programs, Apollo, Luna, Chang'e, Chandrayaan. But about 3 months ago, a small company from Houston managed to soft land, for the first time, a commercial lander on the moon. And there's more of that coming. And so the question is, what would a commercial lunar infrastructure look like, a commercial lunar economy? And so if you imagine that I'm a mining company on the moon, and so again, thinking of the vision of DARPA, let's imagine that future, drag it into the present. What does a lunar economy look like? I'm a mining company. I need a couple of things. I need to buy power from somebody. I need to buy robotics from somebody to give me lunar regolith. I process it, I create a product, and then I need a rocket company to bring that product back here to Earth, back here to you. But how does that actually work? How do I pay for stuff? How do I buy on the moon, pay for robotics on the moon, pay for launch to the moon and back, without dialing back home to Earth. It's the equivalent of dial-up internet way back when. If I have to call each transaction I want to make, get a human to approve it, and then come back to the moon with all of the latency that that involves, that becomes the fundamental limit to a commercial lunar economy, which brings me to blockchain. Zero trust is just a geopolitical reality we live in. We need machine-to-machine, peer-to-peer transactions, microtransactions that can happen without humans in the loop. And that's part of what I'm researching at the moment. And I think that leads perfectly into what we're probably going to talk
I
about.
think the zero trust is a common theme about people who've had a. To me, I think on each study, one of us has been to space. There's a cosmic perspective. It's what I always love with space. Is more the cosmic perspective, like just relative, us being, flying on a rock across the galaxy. But going back to some more detail on the technology, Mike, you mentioned a few things on what DARPA had come up with as such. We know everyone knows 5G, but Scotty is a bit of if you can introduce yourself a bit more,
Yeah,
and
sure.
then tell us a bit more how typically something that most people know as on Earth as 5G, how is it different in space, for example?
Yeah. Okay. Great. So Scott Hasbrook, CTO, SpaceCoin. Tay mentioned I kind of inspired him for this idea, and I guess convinced him to start the company and make me CTO. So I've been three things ever since I was about 12. I've been an absolute space nut. I volunteered at a space museum in my hometown. I met Jim McDivitt and helped give tours of his Apollo 9 capsule. And I was an aviator when I was 12, pilot's license when I was 17. And then I started my first business when I was 12. I've been engineering software ever since, back in the early days of the internet over dial-up, actually making a reference to Earth to Moon communications. Done a couple tours in Y Combinator as CTO both times, and started probably 4 or 5 companies, soft exits on some, decent exits on one. And my educational career was as a scientist. I was a chemist and a physical chemist and a spectroscopist. And that leads me up to GLUA. I was actually, for 2 or 3 years, I was an engineering manager, was VP of engineering, and became head of SpaceCoin about a year ago. And then, officially, obviously, this was somewhat of a covert secret project we were building. And that leads me to the 5G technology. So it's an interesting combination. So if 5G, the way it works currently on your phone, is you have a fiber optic cable going to a backhaul of the internet, and that fiber cable goes to a cell phone tower. It's about a $250,000 structure over the side of a building with maybe tens of thousands of dollars of radio equipment and what's called a panel antenna on the front of it, and it propagates a signal out in a direction like this, sweeping about 20 degrees. Right, and this is in microwaves at about the 1 gigahertz range, what we call L-band in the business. And it's essentially a handshake using a SIM card or an eSIM as a passcode. I'm abstracting this and making it very simple. And so you have a round-trip path of anywhere from meters to kilometers to what's called the G node B, or the access point in the radio on the side of the building or the tower, to your phone and back. So the way radio waves propagate, they are absorbed. They're a form of light. They're just a very, very, very low frequency form of light, well below infrared radiation. So they are absorbed by buildings quite a bit. They're entirely blocked almost by buildings. So in a building like this is why your signal is quite a bit weaker. If you go into an airplane hangar that's all metal walls, you have almost no signal, or maybe like a Walmart store, right? And then you have foliage like trees, and then you have rain. It's ultimately also about the geometry of it. You really can't reach more than 5 or 10 or 15 kilometers until you run into terrain or buildings or trees, and then your signal stops. So all that means is this is a great solution in a city like we're in Seoul, because we can just throw up access points everywhere, spread them out on spectrum. We have something called frequency coordination. The G node B is all talked together. 5G is really an amazing technology. Really, the architecture behind it in the layer 2 and the layer 3 underneath the G node B is pretty interesting if you dig into it. All that to say, it works great in dense population areas. It works pretty decent also in suburban population areas. You have less towers, less access points, but they can reach further because there's no buildings or there's only small buildings. The real challenge of it comes when the cost of a fiber optic cable underground, when you factor in permitting, the construction, the civil engineering of it, and the actual cost of running the cable is about $50,000 per kilometer. And then the cost of building the tower is about $250,000, right? So if you run fiber optic cable, say 5, 10 kilometers, and then build a tower, that's $1 million to give access to, in Seoul, maybe that tower can give access to 10, 15,000 people. Economics there works out. If you're in the middle of Africa and you need to run fiber optic cable 300 kilometers and then build a tower to give access to a village of 500 people that live on tens of dollars per day, those economics will never work out. It's not a technology problem. It's an unit economics cost problem of how the infrastructure is architected. What this solution does is we spent 2 years figuring out how to take a 5G access point and cram it into a box the size of the stools that you're sitting on, and then build an antenna and a very powerful amplifier that can reach all the way from Earth and back to a mobile device. That's what we did. And then we're going to put that on a blockchain. So the difference is there's a couple challenges. Maybe you want me to get into that later, and we can go back to the rest of the panel. That's essentially to set you up what we're going to talk about. We took a 5G access point, put it in a box, and we throw it in space on a rocket.
You got to talk about latency.
Oh, yeah.
Okay, so this is the key thing.
Yeah.
If you have a geosynchronous satellite up there, which is the way we all started, it does take radio signals and it will bounce them back. So it moves at roughly the speed of light. So it's 23,000 miles out in space. It's 23,000 miles back. So that's 46,000 miles. Light goes 186,000 miles a second. So you've got about a quarter second pause. So if you try to have a telephone conversation with somebody like this, it's extremely difficult. You constantly interrupt because when you finish, there's a pause. You're waiting for the other person, but you're not sure they've heard. So this is the key that Sid's talking about with VIA. This is what the antenna does. It brings the satellite low enough so you don't notice the latency in the transmission. It sounds just like you're talking on a telephone, and you can go back and forth.
It also means we can have smaller satellites. So our satellites, maybe they're around $1 million or $2 million, to give you an example. A single satellite that can connect 50,000 devices is about the same cost as a few kilometers of fiber and a tower. And when you bring them closer to Earth, as you said, you solve the latency problem. It's a few hundred kilometers of light delay is tens of milliseconds. It's unnoticeable. And then the cost, that space environment that's closer to Earth, you still have quite a bit of protection from Earth's magnetosphere. When you go to geosynchronous orbit, it's a much harsher environment. You have cosmic rays, you have charged particles from the sun, and you have to have very expensive hardware. Those satellites start at $500 million a piece. And then you have the problem of how do you make that satellite now serve millions of people instead of one small satellite that you can replace every 5 years when they deorbit that can serve tens of thousands.
Mike, did you want to add something?
I think that's a great introduction to exactly why the moon is so hard. So if 23,000 miles is hard, 300,000 much harder.
Let's go back to more like nearly a philosophical or more a political question around essentially, internet as such, or started, the very decentralized fashion for research as such. We know it's extremely centralized nowadays. There's all sorts of reasons why, infrastructure, gains from efficiency by being actually centralized as well. How do you see this being compensated by essentially space communication, or how do you see like decentralization is in some ways just reinvented as we go into space?
So because we are beaming from space instead of building a ground station, we are able to serve many people from, while it's a constellation, but from a couple of hundreds of satellites across the globe. So this allows people to be a part of telecommunication infrastructure without actually having to have billions of dollars to invest in building an infrastructure. So this allows people to, also putting on a blockchain allows people to use this infrastructure without actually trusting any centralized party, so that give access to people to without being censored or being filtered with a great firewall.
I don't know if one of you wanted to take the same question. Actually, it's quite open.
I'll take it. Yeah, I'll take a shot at it. I've got white hair, so like somebody else mentioned up here, I was around when the internet started, and it actually contributed a lot to our second mission. In '94, we were imaging about 500 sites around the world, and there were a lot of communications and agreements. There's a lot of agreements with different countries about imaging on their sites in their country and who would be gathering data and everything, and things became pretty dynamic. And the internet came along, and scientists were able to communicate back and forth using the internet. And and the geopolitical situation was a little bit different back in 1994. We didn't have, several wars going on in the world and everything, and countries were talking to each other in a little bit better tone, I think. And so at any rate, there we were getting ready to fly, and we had American scientists sending emails to Russian scientists and telling them what data they needed on the ground, and the Russians sending things back saying what they'd like us to collect on the vehicle. And the governments, the organizations, even NASA was sort of out of the loop. I mean, it was just scientists talking to scientists, people talking to people, and I thought it was beautiful. And I imagined, this was the future. I was a little bit naive, and then things came along, and we wound up with search engines that maybe don't search for everything you wanted to. Maybe they leave things out. We wound up with platforms that maybe don't allow you to talk about everything you want to talk to. Maybe they censor certain things and stuff like that. And so I'm hopeful that I was excited in the early 1990s, and that excitement got dashed by what eventually happened. I'm excited that maybe this will decentralize the internet again and enable those scientists or other people or people in these underserved populations of the world that have talents that they can put to use and needs that they have to be able to get on the internet, communicate with who they need to communicate with, and get us back to where I had hoped we would be going originally.
So,
Well, some countries may not like this.
Gen-
And you know what I'm talking about, right?
Yeah.
I mean,
yeah.
right now, and just to be very practical about this, if you look at what's going on in Eastern Europe, the Russian people don't really understand what their armed forces are doing to the country of Ukraine. They're kept in the dark deliberately. All the information is controlled. And since the internet was developed, China and Russia both put a great deal of effort into being able to ensure that internet service providers could not access their populations without going through controls. And so what this will do is make it much more difficult for the great internet wall of China and for Russia's centralized control to prevent the flow of information. So we think this is a good thing, and we think it would be very difficult for them to jam these satellites. It'll bring up all kinds of international law, all kinds of problems, and we've just got to move the world together. We've got to bring people together, provide information, let people see the consequences of their actions and the consequences of their government's actions. And so that's what this is really all about.
I think Scott actually has the numbers, right, on how many people in the world are being censored and how many people don't have access to
I have the
internet,
rough
and
numbers.
it's significant.
It's not publishable. Don't quote me, but ballpark. So it's more than you'd think. It's roughly 2.8, 2.9 billion people are unconnected. One of our partner nations is Nigeria, country that we've done a lot of work in, and emerging market lending. We believe it's about 38 to 39% of the population remains unconnected. Now, Starlink, for example, is everywhere in Nigeria, but that is a system that was architected with a larger architecture for high-performance fixed satellite service. So it's designed where you need $500, hundreds of dollars of equipment to install it. They are sort of working on a mobile service that's really unclear, but again, it's re-architected not on open standards, and it's going to be very expensive. It's designed for users that want hundreds of megabits per second that are willing to pay $100 per month. Well, when you live on $10 US per day, that's simply not an option. Ergo,
Zero trust, right?
it's an O&O, and it's not zero trust. And we've seen that, actually. There's been several examples where that system has been turned off for certain people unexpectedly that had various impacts that were rather significant. So there's roughly 3 billion people, or just short of 3 billion people, that are unconnected. Furthermore, of the people that are connected, there's about 3 billion people of those that are censored in a major way by their governments or by the centralized companies that are controlling their connection. So I think there's a lot more problems to solve on the application layer of the internet. Sid, you were mentioning perhaps search engines don't show you everything, or perhaps now we have AI content that's generating fake news and swaying elections and whatnot. Those problems all are going to be future work that has to be. So this is a difficult problem. There's a lot to be solved here. I think our organizations here on the stage and what we hope to build with decentralized even ownership and operation of these satellites, by allowing open sourcing them and allowing others to actually join the network and operate the satellites. This won't, at the end of the day in the future, this won't be a closed constellation. It'll be an open constellation. So when you have multiple satellite owners all working together in a constellation and an open standard, an open published standard on the open standard of 5G, and opening the standard of how satellites talk to other satellites and then to the ground stations, we think that this is probably the best shot Earth has at solving the centralized terrestrial infrastructure that can't be solved because it requires digging up ground, buying land, getting permits. With this, it's in the air. It's like Nikola Tesla's original vision for electrical power. It's open, free communication in the air that we hope will set the world up better to solve the application layer of allowing people to talk freely with one another.
Thanks, Scotty. I knew of the Russian number, like 140 million people or so, and I think 2 million of them had access to a wider internet, essentially.
I think so. It's something like that.
I wasn't aware that was.
I don't remember the specific. It's enough. It's significant. Yeah.
And Mike, you wanted to double click on that. I think there's
Yeah, I think so. This is a great discussion. So I'll just add one thing on top, which is that these guys are practically working on today's solutions. Part of my job is to be a futurist and think about tomorrow's problems. And so this is a great setup. And if you guys have questions after, please feel free to bring it up. But what I'll just add is that a future, so thinking about it, that future lunar economy that I mentioned, the number to keep in mind is $1 million per kilogram, US dollars. That's what it costs to drop 1 kilogram, take it from Earth, and drop it on the moon. And so you can imagine that every single application you put there.
It's what, $20,000 to put the killer in space?
It depends on who you buy the rockets from. VIA will bring that cost down and make it to. It's different because it depends on what orbit you need to go to. If you don't care, you can buy it cheaper. But for solutions like ours, where we have to engineer the orbits, we need smaller, low-cost rockets. But in the end, yes, it's about $10,000 to $20,000 per kilogram.
I mean, it's
compared
still
to 1
massive,
million.
like 50x to go simply from being in orbit to go to the moon. It's
Correct.
It's a good number.
50 times, yeah.
Right.
And that's one way to the moon.
Right, that's one way. And so
You don't get back for that.
yeah, so it's fragile, right? What that means is that if you don't deploy it correctly, if it's not low latency, if it's not zero trust, if you leave this stuff out, this fledgling lunar economy, our first ever off-Earth economy, could very easily fail. And so thinking about these problems, architecting these problems early is really important so that that $1 million per kilogram is well spent. And that's kind of the future of where this is going.
I actually view solving the problems here on Earth, the economic problems of connectivity and decentralization to mitigate censorship, is the test bed for what Mikey's talking about of the 10 to 20 year vision of now humans moving off-world for the first time, not just to go camp out like the Apollo astronauts did, not to diminish their great accomplishment of walking on the moon, but to actually go live and work off-world. I think what we're doing here is the test bed for that future.
Yeah. If you want to do peer-to-peer transactions on the moon, there has to be a way in which to do it. We got to defeat the latency that the general mentioned. These are difficult problems, and if you don't think about them now, then when we show up there saying, okay, commercial lunar economy, we're ready to go, and we don't know how to create the Square app for the moon, we don't know how to create the Amazon marketplace for the moon, if those don't exist, then that economy could fail.
Right. How do you buy a vegan hamburger on the moon? Who settles the transaction, and what currency are you paying? I'd argue it's going to be Space Coin, but I'm biased.
And it has to be vegan because of the cost of producing
Well,
meat
who's going
and
to grow
space and stuff.
cows and
We're not going to go
and
down
pressure
down the
chamber
route
the
of
moon.
that
Yeah,
one,
yeah,
but
so.
but
Yeah, maybe we can grow meat, but that's other people are working on that.
maybe to take a very different sort of tangent from like freedom, for example, into especially more like societal like impact, and then just going back to general on how do you think that space, essentially space development, will impact the societal changes?
Well, I think the best way to start is to tell you that I was in South Sudan about 10 years ago looking at a U.S. Agency for International Development project. And the U.S. had helped develop a cassava, which is a tubular plant that's used for food in Africa. Now, the normal cassava is, it's about this long. It looks like just part of the bush, but when you dig it up, you can't eat it. It looks like a carrot that's white. You can't eat it because it's poisonous. So the U.S. Agency for International Development did some hybridization and could produce a cassava that wasn't poisonous. In other words, this plant would keep its root structure intact for up to 2 years, and you could dig it up anytime, shake the dirt off of it or wash it, and eat it like an apple or a potato raw. Okay, we asked this woman to describe it. She said, well, this is my family's emergency food supply. And we said, well, could you grow more and sell it on the marketplace? She said she would not do this because she would be cheated, because the people who would buy it know what the price is, and she doesn't know what the price is because she's in the middle of nowhere. She's not connected to the internet. She didn't have a cell phone that worked out there, and so she knew she'd be cheated, so she wouldn't do it. Now just think, how many people in Africa, in Central America or South America, in Southeast Asia, don't have ready access to market information? If they had that information, they might change their behavior. They might grow different crops. They might change their buying habits. So this could have a very significant impact on the global food crisis that we really face. You know, what we've done over the last 75 years is we've encouraged people in the tropics to eat food that comes from the temperate zone. So they don't grow wheat. Well, they want bread. And so they grow cassava, but it doesn't have the value and it's not distributed. So if they grew cassava, if you could make cassava flour, and then you didn't have to spend your scarce money importing food, you would import technology or educational materials. It's a different way of bringing advancement to countries. That's what this system could offer to this woman in South Sudan and hundreds of millions of people elsewhere.
Sounds fantastic. So in a framework of doing this, making those changes long-lasting, going back to Sid actually, is how do we make a space technology as such long-lasting itself, considering the conditions out there?
Well, the technology is, space technology in general, I think will be limited by the advances we're making. The same reason, your cell phone, when was the last time you had a cell phone that actually failed and you had to get rid of, right? I mean, not very often. More often you change your cell phone because it doesn't have the capabilities and everything of the new cell phones. You want the new capability. It's much more efficient, much more effective. You can be more efficient yourself with the new cell phone. I think space technology will be similar. And there will be similar lifetimes for it, like 3 to 5 years or whatever, I'm thinking. I mean, the satellites themselves in low Earth orbit can probably last a lot longer, but at some point, the satellite provider, the satellite operator will say, okay, this is no longer efficient to operate this satellite because, I can replace 5 of these satellites with 1 of the new one or whatever, or a satellite 1/4 the size or whatever. So I think that's what will drive it, is the general advancement in electronics and technology. But that's good news, right? Because we'll be getting more capability out of what we have up there in space.
Thank you. I don't know how much more time we have, but as long as they don't kick us out, we'll just stay here. And then,
Why not? Let's do it.
no, we will. Just one last question before opening up is that for entrepreneurs, investors, people who want to get involved with the space, I'm one of them, and then don't necessarily know where to start. How would you go about it? So if each of you can actually give a short answer, that would be quite nice.
The question is how to get involved in space in general, how to get involved in space coin.
Space economy, space con.
Oh, yes, yeah. So I think I'll take it from the builder's perspective, just because I'm the lead of the engineering. I'd say if you want to get involved, send me an email, find me on LinkedIn. I'm looking for a wide variety of engineers. We'll need blockchain engineers to build this. If you want to build the first blockchain constellation, Substrate. We talked to John here, and then I think. Really, what I'm interested in is I'm looking for people that are want to write embedded software on board or doing FPGA work. That's what I'm looking for. So,
Thank you, Mike.
Yeah, space economy. I'll take it from the investor perspective. I think that if you're looking to invest, two things you should know. The first is space is the future. I think you've heard a lot of that from these esteemed panelists today. The second is space is hard. So if you are thinking about investing in this space, get your big boy pants on, because there's a lot of risk to be taken, but there's a lot of reward to be had. Space is the future. Space is hard.
General, maybe you have a...
No, I think you have to start at the software side if you're an individual entrepreneur on this, because you don't have the ability to get the hardware. So my basic recipe for entrepreneurship is this. You have basic skills, find a company that's doing something you like, get with the company, learn how to do it. Find people that you like in the company. When you're ready to launch on your own and you have your own idea, then you take that launch. But you make sure before you do the launch that there's no failure mode that is going to be inevitable that you hit. And you make sure you have the personal survival money to ride with the company for a couple of years. If you do that, and most people do it in software, because what they do is they join a company, they find what's going on, and they say, aha, there's a more efficient way to do this. We cut out a step, we do this, we do that. And this is really the way that so many people have made it in the software business. They found inefficiencies. So I would invite you to come to the United States and get rid of credit cards for us. Now, we've been trying to do this for the last 20 years. We can't break through the commercial banking system because they're charging 2.5% on every purchase that goes to the bank for handling the credit cards. And so that's a huge inefficiency. There's got to be some way to cut this out. In Africa, they're doing it with mobile money. And so you just buy the minutes on your cell phone. With SpaceCoin, it's going to be exactly the same thing. You're going to cut out the commercial banking system, and that's going to be more efficient. I just hope we'll bring it to the United States and make it popular and usable there. So I just have to have my cell phone and not a wallet with a credit card.
There's actually a pathway for that. It's called 5G unlicensed. It's pretty exciting. There's a potential pathway. Other than that, everyone's hoarding Spectrum, but yeah.
For the audience, it's not necessarily ironic. It's very interesting to see the general actually saying this, being ex-Goldman Sachs, and and especially from a U.S. context where every pictures of a European or an Asian talking about an American is having 30 different credit cards or something like this, which is probably the minimum number you need to survive over there. And it's just it's a very interesting context. So I'm also all about efficiency. So
the United States, we're not leading technical innovation in many areas. The technical innovation happens elsewhere. We've already got our infrastructure plugged in. Our electricity net is a hodgepodge. It's not up to date. The same thing with our communication system. The same thing with our banking system. So when a country like Korea is building fresh, it's more modern than the United States. And this is going to be the case also in much of what we call the lesser developed countries right now, because companies like Glua are going to take this and hyperspeed their infrastructure. So Indonesia won't need 1 million miles of fiber optic cable.
I think you're spot on that. I think we'll have more internet-connected phones in a few years or 3 years in Africa than there are in the United States. I think that'll eclipse it very fast for that exact reason.
Talking about building and rebuilding, I want to go to Sid on, very much being a builder in the space economy.
So my advice would be a little bit different than the general, because he's talking to you about how to make money, and I'll be talking to you. So if you want to go do something, I'm going to talk to you about something a little bit different, and that's my advice would be pick a really hard problem, okay, and try to solve that. And you may not make a lot of money on it, but if you do make money, you're going to make a bunch of money because it was a hard problem. And so I told you I wanted to be an astronaut when I was in the 5th grade or whatever. And I was inspired by our president at that time, John F. Kennedy, who said, "We choose to go to the moon, not because it is easy, but because it is hard." And so I've kept that in mind. I led a group of people at Sandia National Labs. We solved very difficult national security problems for the country and for other countries and for businesses. And when they would come to us, I would tell them, if you have an impossible problem, that means there are only 3 possible solutions to it, okay? If it's not impossible, we'll give you a lot more solutions. The point being, to solve hard problems, you need to be optimistic, and there are solutions out there. Everything we've been talking about, there are solutions to them, and that's what I would recommend. Work on the hard problems.
Thank you. And then going back to Taya.
My comments as a business owner running a business. So whenever a software engineer tells me that it's going to take 1 million in 1 month, I triple it in my mind. It's going to take, but when it comes to space, I times 10.
Accurate.
It's much harder when you actually start it, because it's not software. It's not, you cannot just like click deploy and upgrade your system. You actually have to wait a year or 2 to deploy your next version of satellites. And yeah, so prepare yourself before starting, but there's so much opportunity in this industry, so I hope more people join this.
Mike, you want to say?
No, I would.
You're just
double-click that.
approving. You're just nodding.
Space is hard, but big risk, big reward.
Come join us. Yeah.
We're gonna open the floor. If you can, I don't know if we can pass the mic around. Do we have more mics on the floor, or should I just go? I can just stand and do the ops. If you can introduce yourself before you ask the question, let's keep it short, and then if you want to direct a question to someone specifically on the panel, do that. I don't know if he wants to show of hands. No. Oh, sorry. Sir, I cannot see you behind the light.
Hi, Stuart from Spacecoin, so slightly cheating. But if you look at crypto and blockchain technologies today, they get a lot of regulatory pushback from incumbents, also from governments. And if you project out what we're trying to do with Spacecoin and other space economies, how do you see that evolving? I guess this is potentially a geopolitical question as you start to eat the lunch of a lot of large incumbent embedded either companies, or also as you start to tread on the toes of nation states and governments able to bypassing some of these great firewalls and so on and so forth. Just interested to see how you see this potentially playing out and the implications of technology such as this, which can really disrupt the status quo.
Well, I'll start on that. Look, nations want their own currency, and nations want to protect their currency, and they want to use it to control the economic development and economic environment in their country. So nations are not going to immediately drop their national currencies and go to Bitcoin. Sounds like a nice dream. It's not going to happen. And so this is, the world is complex. There's plenty of room for cryptocurrencies with national currencies. There's, there are places, there are circumstances, and eventually, if we move forward together and bring people together, we won't have these issues that we have now. But what you have going on in the currency market today is you have the United States with its fiat currency. It's about 60% of world trade. You have China trying to create its BRICS currency for Brazil, Russia, India, China, South
Turkey
Africa,
just signed up.
and now a number of other countries have joined. Turkey's now applying. And they don't want that to be fiat currency. Nobody trusts the Chinese alone because of what they do with currency manipulation. So they're thinking it could be backed by gold. But the thing about backing a currency by gold is that gold has no intrinsic value. You can't eat it. You can't smoke it. You can't grow it. It's heavy. Now it is scarce, but the truth is it's not nearly as scarce as people think it is. And with new progress in chemistry and other things, alchemy is not far away. So if you think that gold solves all the problems of fiat currency, you better be very careful. So really, it's all about trust. And I come back to blockchain technology. Blockchain technology is the basis of trust because it's a ledger that's not erasable and it's universally viewable. So that's the foundation. So I think, Stuart, what I see in the future is contending struggle between fiat currency of the dollar, a new BRICS currency. There's a ruble trade arrangements being set up for Russian oil that's gone on for the last couple of years. There are various agreements that they can pay for oil with Chinese renminbi. But all this is transitory. It will continue to evolve. And there's room in this system for lots of different currencies. There will always be people who want to make market between these currencies and between the cryptocurrencies and the fiat currencies. It's just the way the world works. So I think we've got a really great start in something different with blockchain. And now let's make it accessible.
Thank you.
First, thank you for the great discussions and innovation from so many of you. I've been, I guess, helping Africa also for the last maybe 25, 29 years. Blockchain, great technology of trust. Africa went from having no fixed phones to mobile, so they skipped one. And I think satellite helps a lot. Then came something along where governments starting to regulate air frequencies. And for example, the price of like a mobile cellular phone went through the roof not because the phones are expensive, not because the cellular towers are expensive, because people decided to regulate space or regulate free air. How do you see this as an issue, or how to maybe address this issue in the context of satellite in your solution? So,
the spectrum is regulated for a good reason. For example, I'm just repeating what I learned. For example, Wi-Fi technology was not widespread because it has no inherent architecture to regulate the spectrum to not disturb each other. So for example, when I was living in a dorm, when I was going to college, I was getting my Wi-Fi jammed all the time because there's like 60, 70 Wi-Fi routers on the same floor, everyone running, like disturbing each other. For that kind of reason, governments or any regulatory body has to regulate who's going to use what kind of spectrum so that they can avoid it disturbing each other. So I don't think this is an obstacle that blocking us from progressing. And also, there are technologies that allows you to moderate between different nodes of the network to avoid interrupting each other. So that's a technological go-round that we can also get implement in our system too.
I'd follow that up. That's exactly correct. And really, what you need is it's a protocol. You need a protocol, and with the devices in your hands and pockets, it's an international organization called the 3GPP that creates that standard. It's so we're currently on our satellite runs on what's called 5G release 17. There's a specific version of it called non-terrestrial networks. The physics is slightly different when you're a vehicle going 17,000 miles per hour overhead. You have Doppler shifting, the frequency shifts. I won't get into the details. Come find me afterwards if you want to nerd out about it. But what is spectrum is a scarce resource. It's scarce per unit air, right? There's only so many megahertz or kilohertz per part of the air. So what is happening, though, is our devices, we're getting better at building small radio technology that can go higher in the frequency, so we're creating more landscape. And now there's a second organization called the ITU that is basically like a coordination layer between nations. And what's very exciting, we looked at what happened with Wi-Fi. Wi-Fi uses what's called the International Science, I forget what M means. They're open bands. And it uses, rather than a company owning spectrum like one would own land, like mining rights in a way, it established what's called automated frequency coordination. So your Wi-Fi routers and your Wi-Fi devices, the access points actually run basically like a quick lookup table, and there's automated algorithms that kind of balance out and make it equitable use of spectrum between all the devices in the room. This is happening right now as we sit here with Wi-Fi in the air that we're breathing. So what's very exciting is now the ITU has gotten a large number of countries on Earth on board with the idea of unlicensed 5G. So, in a lot of the countries, we are going to work in the licensed spectrum, and that's a problem we're able to solve. But this is going to quickly, the world is moving in the direction of open standards and unlicensed spectrum with automated frequency coordination, which also you can run in a decentralized manner, the automated frequency coordination. So you're absolutely right, it's a challenge. This is a hard problem, and we can solve it now on licensed spectrum, and we are and we will. But I think the world is moving in a direction of seeing the success of Wi-Fi and applying that to 5G and 6G devices.
So I want to just pitch in with one thought. So in the early 1990s in the United States, a couple of engineers discovered that they could create a spark that was up 2 to 3 gigawatts in width, and they could actually slice that spark that had a duration of maybe half a second or less than a second into millions of pieces. And in those pieces, they could embed information. And so they formed this company called Time Domain. And they, if they used it, they discovered that it didn't actually interfere with the frequency spectrum because the spark was so instantaneous and it was such a broad base that, and it was, it carried a long way. So they went to get it licensed by the Federal Communications Commission. But the FCC checked with the existing cell phone companies, and there were several at the time, and they were just getting started. And they insisted that there would be a problem, and they insisted on testing. And they were able to prove to their satisfaction, or to the satisfaction of the political people that control the Federal Communications Commission, that this time domain technology was going to be a threat. And it was mostly a threat to their investments in spectrum. And it was also a threat to the government, because the government auctions spectrum. And that $1 billion of auction is part of the U.S. government budget. And when the U.S. government regulators decide on something, it's manufactured and it permeates the world. So it won't be very long in the future before we have a different technology than the use of the spectrum as it is today. Time domain will come back. It may come back in Africa, may come back in Nigeria, it may come back in Antarctica, but it will come back, or something like that. because human ingenuity will find a way through the artificial constraints on bandwidth. It's just going to happen.
Thank you so much for the call. One last question, I think. Oh, yeah, go ahead. Thank you.
I am an advisor to GLUA, but as an advisor, one of my responsibility ask questions. So I have a question to Scott. We already have a satellite link called Starlink. Why we need another satellite link? Your name is Space Coin, right?
Yeah, that's a great question. I think it's twofold. A bit of it I answered earlier. Starlink was architected from the ground up, quite literally into space from the ground up, to be a high data rate architecture, right? So this is great for countries like if you're in rural Korea or rural United States where you have a large income and you live 50 or 100 kilometers from a large city. It is great for that. And you have, maybe $100 US or $200 US per month that you want to spend on 100 megabit per second internet. That blocks out like 0% of the probably 0% of the 38% unconnected in Nigeria. It's an economic issue. The second one is Starlink is owned entirely by a private company called SpaceX. And that presents a problem where if the future version of the global internet is owned by one private company, they're not even public, and they have a very vocal and flamboyant a leader at the top that can choose to turn it off when he or she wants to, that presents a problem that needs to be solved. So what we intend to do is we intend to capture the market through the long tail of the market of the 3 billion people that have no affordable internet, which 3 billion people times $5 or $10 US per month, you do the math, it's a very, very substantial market opportunity. And we tend to leverage high margins on that because the margins of this, based on the cost, it's like 90% estimated. So we intend to leverage those margins to grow an open network where the satellites and the ground stations are owned and operated by a wide variety of, no one party controls the ground stations. So I think there's other problems yet to be solved in terms of differentiating ourselves from that, but those are the two big ones in my mind.
Is that second one essentially saying that's why you need blockchain?
Yes, correct. Yeah, well, decentralization from a network standpoint, just the network architecture, regardless if you're running it on a blockchain, decentralizing the ownership and thus also having open standards, optical links and RF links from ground to space, space to space, and space to device. The open standards and decentralizing the ownership of that hardware infrastructure, but then also decentralizing, the transaction layer of it. Yes.
Tay, you wanted to add something else? Or no? You forgot. It's okay. So if you have more questions, I think we'll wrap it up quickly. We had about just 5 hours of material as I mentioned when we started as such. I'm quite delighted of the warm discussion we've had. I've had very, very little work to do to redirect the flow. I think we were quite good at bouncing balls from each other and so on, and just managing the flow of the discussion like a good drink at a bar with friends. So it's really good. Just a little round of applause for the panelists, and thanks for listening.
Thank you.